Now on this domain and range series of videos, this will be our last video. So in this one, I'm going to address things like horizontal asymptotes, vertical asymptotes, and then yes, those type of stuff, especially those. Okay, so now these happen in two graphs, ne? And for a straight line in parabola, you saw how to find the domain and range, right? For more examples, please do contact me, and then we can take you through them. Now in this one, we're going to show you vertical asymptote and horizontal asymptote. This happens in two types of graphs: a hyperbola, right? A hyperbola, which is the general form y is equals to a all over x plus or minus p plus or minus q. And then it also happens in exponential, right? In exponential, which is y is equals to a b x plus or minus p plus or minus q. So in these two graphs now, we're going to have what we call a horizontal asymptote and a vertical asymptote. Okay, so starting with the hyperbola, which one is the horizontal asymptote, which one is the vertical asymptote? Well, your q, when you say y is equals to q, that will be your horizontal asymptote. Okay, y is equals to q is called the horizontal asymptote. Okay, while x is equals to negative p is going to give you your vertical asymptote. Your vertical asymptote. Let's give you an example. Okay, let's just say I have, just for example's sake, let's say you are given, so this is an example, and let's say you have y is equals to 2 all over x minus 3 plus 1, and you have to sketch it. Okay, well, your horizontal asymptote will be y is equals to q. Which one is your q here? Is 1. So y is equals to 1 is your horizontal asymptote. While the vertical asymptote, you're just gonna take whatever is here. You're gonna take whatever is here and equate it to 0. You're gonna say x minus 3 is equals to 0. Therefore, x is equals to 3 will be your vertical asymptote. So this is your horizontal asymptote, vertical asymptote. If you were to sketch this graph, okay, you have to remember that if a is positive, your graph will be in the first and third quadrant, right? But if a is negative, your graph will be in the second and fourth quadrant. Okay, so in this case, our a is positive because we have y is equals to 2, positive 2. So our a is positive. It means our graph is going to be in here, and then it's also going to be in here. Right, in the in the first and third. Remember, this is 1 2 3 4. So let's quickly sketch it. Right, you start with the horizontal asymptote, y is equals to 1. It means you cut the y-axis at 1. Remember, this is the y-axis. You're gonna cut it at 1, like this. You cut it at 1. Then this is the graph of y is equals to 1. Then this one says you're gonna cut the x-axis at 3. Remember, this is your x-axis, right? This is your x-axis, this one. You're gonna cut it at 3. You're gonna cut it at what? At 3. You're gonna cut it at 3. So x is equals to 3. Okay, so this point here, it will always be x is 3, y is 1. Okay, so now when you have to sketch this graph, it will be in the first and third quadrant. You just look at this as a Cartesian plane, say this is my first quadrant, my second, my third, my fourth. So your graph will be in the first quadrant, and then the third quadrant, and then the third quadrant. Well, you have to know what is the y-intercept so that you know what is this point, and then what is the x-intercept so that you know what is that point. So that one is a bit of a story for another day. Yeah. for now, this is the general shape that you would have for that graph. All right, so here I want to address the issue of domain and what, and range. So how would you find the domain here, and then how would you find the range? Okay, well, the domain, we're going to start with the domain. Remember, domain is x values, and we're going to start from the left, right? I'm going to start from the left all the way to the what, to the right. So when we start from the left, let's look at our graph. Is this our first point? And then is, remember, we're going to say x is an element. Is this our first x value? No, it says there is another point here. So is -3 our first x value? No, it says there is an arrow. It means this graph goes like this, right? So it means if I say this is the first x value, there is another point here, there is another point there. So it means the first x value is at -infinity. So we're gonna say it's at -infinity, right? Then where do they end? You go now, like, remember, you move from left to right. So you're gonna say left to right, left to right, you move. Well, the graph seems like, look at this point here, there is an x value. Look at this point here, there is an x value. Look at this point here, there is an x value. But now the graph seems not to cut this line of 3, ne? So you're gonna say, okay, it means my graph starts from -infinity, it ends at 3. Okay, it ends at what? At 3. But we don't include that because it's a vertical asymptote. The graph does not touch the vertical asymptote. So we don't include the 3, we use the round bracket. Then we say union. It means our graph took a break, né? And then it started here again. It started here. Look at this point here. There is an x value. And look at here. There is another point there. There is an x value. So it means our graph ends at 3, and then it also starts at 3. Okay, it then starts the journey again at what? At 3. We don't include it because the graph is not touching the vertical asymptote. And then after that, where does it end? It goes here. There is an x value. Is it our last one? No, there is another one here. There is another one because there is an arrow, so we say it ends at +infinity. So that's how you write the domain of that one. What about the range? Okay, what about the range? Well, for the range, you're going to say from down, right, down to where? Up, ne? So when you say down to up, right, look at your graph here. Is this our first y value? -3. No, there is another point here. Is this our first y value? No. Remember, we're gonna write y as an element. So here, is this our first? No, there's an arrow. It means it keeps going down. So it means our first y value is way down, down, down. At what? At -infinity. Then we go up. We go up with the graph. There is a y value. Look at this. There is a y value. Look at that. There is a y value. Look at this, there is a y value. Look at this point, there is a y value. Well, our y values seem to end at what? At 1 here. And the graph is not touching 1. So it means our graph is going to take a break at 1. We don't include it because it's not cutting it. Then it's going to return and start the journey again at 1. Look, the graph is approaching 1, right? There is a point here, and then, so it means we're going to say, just like we did here, our graph is going to return and start at 1. Then it's going to have an x value. This is going to have an x value. This is going this is going to have a y value. This is going to have a y value. Then the last y value will be at +infinity. So it means we will have that. So that's our domain, and that's our range there if we have vertical and horizontal asymptotes.